I'm Tom Margraf. I'm a systems and mechanical engineer for Cornerstone Research Group, and I make flying machines and self-healing skins. A systems engineer is a discipline of engineer that really draws from different backgrounds and different technologies to develop an entire system. What we do is we pull from the fields of materials, space, automotive, aircraft, anything that's got an emerging technology, and then we'll integrate it into a system to develop some kind of new gee-whiz gizmo that does something that nothing else has ever done before to suit a specific need or functionality. Everything excites me about my job. The fact that I get to come to work and I get to build micro-air vehicles and morphing aircraft, really cool functionalities and really things that didn't exist before, that's what excites me about my job. The fact that I can come in and have a different challenge every day and then have the means to solve that challenge is the exciting thing about my job. A couple of projects that I'm working on right now is, one is materials oriented and there's a couple systems oriented ones. The materials one is what's called shape memory polymer. And so shape memory polymer is just a plastic, if you think of a plastic Coke can or Coke bottle, that you can heat it up and you can change its shape. When it cools down, it maintains that shape you changed it to. If you heat it up again, it goes back to its original position. And so we can apply that to different systems. Morphing systems is one. A morphing system is a vehicle or a structure that changes shape. And a good example of that is aircraft. We do a lot of work with morphing aircraft. And so if you can think of a 747 whose wings, when they take off, are in this kind of configuration, and then for a better flight, smoother flight or something like that, they come back into a swept position. That's an example of morphing. Another application of that is what's called reflexive. And what reflexive is, it's just a fancy name for healable skins. And so if you think about an aircraft, think about all the things you see on the outside of an aircraft. That's all skin. And if that gets impacted on the ground with a piece of luggage or in flight with a bird, that skin gets damaged. And what we can do with reflexive or self-healing is we can identify that, yes, the damage has occurred, and then we can actually heal the damage even if the vehicle is in flight. The other project I'm working on is less materials and more system, is what's called micro-air vehicle. The micro-air vehicle is a 10-inch max dimension air vehicle, so very, very small, and it basically is used for surveillance and things like that can translate and fly around. It's also got a really cool capability called obstacle avoidance, in that if there's a building in its way, it can fly up to the building, identify the building, fly around it, and then go back to its original flight course and go to its destination. So those are just a couple of the projects I'm working on. That's 4 out of probably 35 that are going on right now inside the company. We have a very unique work environment. It's a very open environment. We have a very strong cooperative education program, and that we have at any given time probably 25 students, college students running around. Most of the engineers are under 25, so it's very young. It's a very free-thinking environment, and it's very team-oriented in that we're what's called matrix managed, in that for each project we develop a new team. And so for each individual project you work on, you're going to have a different team of partners. A co-op or cooperative education program is something that a university instills, and then it partners with companies around the area of the university. And so the way that I did it, I was 4 months in school, 4 months in work, 4 months in school, and so on and so forth. And so what you can do is, while you're taking classes, you're also developing these skills in a work-related environment and applying them to real-world problems. You're not just dealing in the theory that you get in school a lot of times. A typical day for me doesn't really exist. I mean, I do such a variety of tasks. One day I could be in the lab looking at how load transfers through a micro-air vehicle. I could be looking at how a specific change in the wing positioning from this to this and the morphing aircraft affects the flight conditions. I could be out at a flight test facility looking about the results of what I've been working on actually doing a flight test. I could be meeting with Boeings, I could be meeting with Lockheed's, talking about how to integrate a system into their actual military and commercial aircrafts. I could be doing any number of things on any given day, and so it's really the variety of my job that I enjoy. Failures are something that is going to happen in research and development. We are very oriented at doing things that nobody's ever done before. Nobody's ever made a morphing aircraft before. Nobody's ever made a micro-air vehicle before. And so failure is something that you just have to overcome. It's part of your job. It's expected. We don't aim to fail, but failures do occur. And so what you have to be ready to do is, if you fail at one path, be ready to redirect and go down another path until you find the right path that's going to ultimately lead to success. I use any technology you could imagine because my job is so diverse that it's not limited to, I use an oscilloscope, or I use this piece of equipment, or I use that piece of equipment. For any given day, I might need to invent a new piece of equipment, or I might need to use a piece of equipment that nobody here has ever used before. And so in order to do that, you really have to be able to go out and look and find solutions to problems and do research and really understand what's been done before, and then how I can apply it to what I'm doing right now. And so I don't really limit myself to one or two or three pieces of equipment. My pieces of equipment are really whatever's been invented before and whatever I can think of. The future of systems engineering is really boundless. It's really whatever people's creativity is limited to. Systems engineering is really just a term that supports the development of new functionalities. So if you can dream of a new functionality, there's a systems engineer out there that's going to want to try to develop it for you. And so there's no bounds to really what systems engineering is going to do. I'd say there's really more of a direction. Systems engineering is focused at making things better, easier, faster. And so there's no future of it per se, because the future is so endless and so boundless that it's really just limited to who can think of what and for what application. I wouldn't say there's any secrets that are, big mysteries to be successful in engineering. Work hard, study hard, understand things, don't just memorize formulas. It's really critical thinking that's going to create a successful engineer. You can get through school with just memorization of formulas and applying those to different problems. But when you get into the field as an engineer, you might need to use a formula that doesn't exist. You might need to create one. You might need to merge two. And so it's really the critical thinking aspect of it that's going to create a successful engineer. I would absolutely be an engineer if I could do it all over again. I love my job. I love waking up, coming into work and doing something different every day and solving problems every day and working with people every day. I couldn't think of anything that I would rather do than be an engineer.